So if you look for NO2 plus, there was some mistake. So if you look for NO2 plus is having sp hybridization. It is having sp hybridization for N plus nitrogen plus ion. So NO2 plus will have linear geometry. NO2 plus will have linear geometry. So here it is double bonded to one oxygen, and here this is a coordinate bond. This is having positive charge. So it has linear shape. It has linear shape. Rest all NO2 minus, it is having bent shape 115, as we have seen the bond angle. O3, it is V shape. SO2 is again bent shape or angular shape, you can say. For NO2 plus, it is linear with a bond angle of how much? It is 180 degrees. So it is NO2 plus the correct option. The correct order regarding electronegativity of hybrid orbitals of carbon is, okay, when we speak about hybridization of carbon, sp, sp2, sp3, as I have told you, see what happens when I speak about hybridization of carbon from sp to sp2 to sp3. What is the percentage of S character and P character here? Here it is 50% of S character plus 50% of P character. In this case, it is 1:2. So it is 33 point something percent of S character plus 67% of P character, I can say. Here it is 1:3, 25% of S character, then 75% of P character. So as you are moving from sp3 to sp2 to sp, what is happening? The percentage of S character is increasing. Yes, as the percentage of S character increases, electronegativity, as percentage of S character increases, electronegativity of carbon increases. Yes, so electronegativity of carbon is not fixed. Understanding? You cannot say exact fixed it is so much. It is varies with the state of hybridization. It varies with the state of hybridization. So as electronegativity of carbon increases, how? As the percentage of S character increases. And you know that where S percentage of S character is more, it is more in sp. Yes, than compared to sp2, than compared to sp3. Yes, so here this carbon becomes more electronegative. That's the reason when we speak this carbon means what? It is triple bonded carbon. Yes, when we speak about this hydrogen attached to this carbon, this becomes more acidic. It can be replaced very easily. That's the reason we say the triple bonded carbon containing compounds are called alkynes. They are acidic in nature, we say, because it is only because of the electronegativity of carbon, which is explained based on the percentage of S character concept of hybridization is involved. So electronegativity of carbon is not fixed. As the percentage of S character increases, electronegativity of the carbon also increases. Therefore, the correct order is what? The correct order is sp, more electronegative carbon is, then sp2 and then sp3. Correct? Moving to the next question. Among the following, the pair in which two species are not isostructural. Okay, SiF4, silicon belongs to carbon family, sulfur belongs to oxygen family. Quite obvious, this is only the correct option, because SiF4, if you see, it has got tetrahedral geometry like CH4, and it is due to sp3 hybridization of the central silicon atom. Okay, whereas SF4, it has distorted tetrahedral geometry. What we call it as, it has got seesaw geometry. And why it is? Because SF4 has got sp3 dehybridization. It has got sp3 dehybridization on the central sulfur atom. Because of the presence of lone pairs of electrons. One lone pair of electron is present on sulfur. Yes, therefore the structure, these two are not isostructural. This is tetrahedral, this is distorted tetrahedral, which we call it as seesaw shape. But rest, if you compare, all of them are having almost, they are having same geometries and they are isostructural with each other. Okay, next question. Which of the following has p pi d pi bonding? Okay, p pi d pi, this question has been arised most of the times. See here, when we speak about p pi d pi bonding, if you consider SO3, the correct option is SO3 minus 2. This is called sulfite ion. Okay, what happens in the sulfite? In sulfite ion, see the central atom sulfur is sp3 hybridized. Yes, so electronic configuration of sulfur in excited state, I will write in excited state. So it is here 3s, 2 electrons are present, spin up, spin down, and here 3p, there are 3 electrons, and 3d, 1, 2, 3, 4, 5, there is 1 electron. Yes, so the 3p electrons, they form sigma bonds. The 3p electrons, they form sigma bonds with 3 oxygen atoms with 1 position, like tetrahedron being occupied by the lone pair. The d electron, can you see this d electron? This excluded from the hybridization. So hybridization is sp3. This is unhybridized. This is unhybridized. So this d electron, it forms pi bond. So here it is p pi. It forms pi bond with 1 oxygen atom, that is p pi and d pi. It forms pi bond occupying p pi d pi bond. Yes, it occurs like this: sulfur, double bond oxygen, single bond O minus, single bond O minus. This is the structure of SO3 minus ion, sulfite ion. Yes, so what is our option? So it is p pi d pi bonding is present in sulfite ion. It is not present in nitrate, borate, then carbonate. No, it is present in sulfite ion. Which of the following 2 structures are isostructural? 2 are isostructural. Again, same question. Compounds having same shape with same hybridization, they are known as isostructural. XeF2, we know XeF2 linear molecule. IF2 minus is also linear molecule. Unlike you see other examples. NH3BF3, they are not isostructural. One is pyramidal, another one is trigonal planar. Similarly, we have seen SO3 minus 2 just now we have seen. It is having what geometry? We have seen it is seesaw shape somewhat, and carbonate is having sp3 tetrahedral geometry. PCl5 trigonal bipyramidal, ICl5 it is T shape. Yes, therefore which is correct answer? XeF2 and IF2 minus, because both are having sp3d hybridization. sp3d hybridization. I'll write here both have sp3d hybridization with a geometry of with a shape of linear. The shape is linear. So these 2 are isostructural. The bond length between hybridized carbon atoms and other carbon atoms is minimum in. They have given propene, propyne, propane, and butane. These options are all what? They are all hydrocarbons. Okay. So propene, I'll show you the structure. It is, this is propene, and manage it with valencies of carbon are managed with hydrogens. Propyne is this, triple bond. Propane is single bond. Butane, 1, 2, 3, 4. So the bond length between hybridized carbon atom and other carbon atom is minimum in. Carbon-carbon single bond length is 154 picometers. I'm sorry, 1.5, okay, 154 picometers. I can write it as 1.54 angstrom also. Carbon-carbon double bond length is, see, as bond order increases, bond length decreases, 134 picometers. And carbon-carbon triple bond length is 120 picometers. Okay, so where it is minimum, since there is triple bond here, it will be having minimum bond length, whereas here there is double bond, it will be 134, all single bonds 154, all single bonds 154. So since here there is a triple bond, the bond length will be 120 picometers, or I can write it as 1.20 angstrom also. Okay, therefore here the bond length between carbon-carbon will be, it will be minimum. The bond length will be minimum. So correct option is what? It is propyne. It is propyne. Okay. Which of the following has sp2 hybridization? Immediately work it out. Here only you all work it out. BeCl2. First option, H is equal to half beryllium 2 electrons plus bonded to 2 and 0 0 4 by 2 is 2, so it is sp hybridization. Second option, C2H2, okay, H is equal to half carbon 6 minus plus, it is bonded to each carbon. If I consider, it is bonded to double bond with the other carbon, but single bond. So 6 plus 2 is what? 8. 8 by 2 is what? Valence electrons are 4. 4 plus 2 is 6. It is okay. It is bonded to only one atom, not two, because I'll show you the structure. It is like this. C2H2. This is the structure. So it is only bonded to one atom. So I will write it here. So carbon valence electrons are 4. 4 plus 1. Valence electrons are 4. It is bonded to one atom and it is also bonded to carbon through a triple bond. So 4 plus 1 is 5. It is not bonded. Okay. So it is, give me a minute. Okay. So C2H2, if you see, it will come out 2, 2. Again, the hybridization becomes sp. Third option is C2H6. So H is equal to, C2H6 is ethane, half 4 plus 4. 4 plus 4 is 8. 8 by 2 is 4. Hybridization is sp3. And C2H4 is H is equal to half 4 valence electrons plus 2. So it is 4 plus 2. So 6, 3, it is sp2. So what the question is, where it is sp2 hybridization. So it is in C2H4. sp2 hybridization is present. When the hybridization state of carbon atom changes from sp3 to sp2 and finally to sp, what will happen to the bond angle? Yes, we know that for, I'll write it here only. For sp3 hybridization, the bond angle is what? It is 109.5 degrees and the geometry is tetrahedral. Yes, since it is hydrogen carbon, there are no lone pairs on carbon. So it is correct symmetrical geometry only. If it is sp2, the bond angle is 120 degrees and the geometry is trigonal planar. And if it is sp, the geometry bond angle is 180 and it is linear. So when you go from sp3 to sp2 to sp, what happens to the bond angle? It increases progressively. It increases progressively. 109.5 to 120, 120 to 180. So it increases progressively. Is that right? Okay. Which one of the following has shortest carbon-carbon bond length? So they have given the options. The options are, first option is benzene. I'll show you the structure of benzene. This is benzene. Second option is ethene. Ethene structure is CH2 double bond CH2. Third option is ethyne. This is ethyne. And last option is ethane. So if you see here in benzene, these are all carbon atoms, okay? So these are all carbon atoms. So in one case, there is carbon-carbon double bond. Here it is carbon-carbon single bond, double bond. But the speciality of benzene is that all the bonds are equal. They are equal. Yes. Neither, we know that carbon-carbon single bond length is 154 picometers. Carbon-carbon double bond length is 134 picometers. Carbon-carbon triple bond is 120 picometers. Then here, is it 154 here and 134 here? No, it is same. So in benzene, the carbon-carbon bond length, whether it is double or single, it is same and it is 139 picometers. It is 139 picometers. So where it is shortest bond length? The shortest bond length is for triple bond, because we know as the bond order increases, the bond length decreases. The bond length decreases. So shortest bond is for ethyne molecule because there is a triple bond. The bond order is 3. The bond order is 3. Next, which structure is linear? Which structure is linear? SO2, CO2, CO3 minus 2, and then SO4 minus 2. See, CO2 molecule we have seen so many times. It is linear structure. It is having linear structure. The hybridization of carbon is sp and the geometry is linear. Okay. While CO3 minus 2, if you see, the hybridization is sp2 and the geometry is planar. It is planar. If you see SO2, the hybridization is sp2 and the geometry is angular, that is inverted V. Okay. If you see for SO4 minus 2, the geometry is, hybridization is sp3 and the geometry is tetrahedral. Please do remember all the geometries. Most frequently asked ions only they'll be giving. They'll not give anything different. So SO2, CO3 minus 2, SO4 minus 2, so many times you have come across this. Yes. So you should remember them. Don't sit solving every time H is equal to half into V plus M minus C plus A. Yeah. So SO2, sp2 hybridization angular, CO2, sp hybridization linear, carbonate, sp2 hybridization trigonal planar. Trigonal planar, and SO4 minus 2 sulfate, sp3 hybridization tetrahedral. So which structure is linear? It is carbon dioxide, which is linear structure. Carbon dioxide. Okay. Next question. A sp3 hybrid orbital contains. So how much of, there are total of 4. There is 1:3. So 1 by 3%, 1 by 4% of S character. Yes or no? So sp3, total of 4 are there. So 1 part is there. So 1 by 4% of S character. So only we say 25% of S character and 75% of P character. Right? So 1 by 4% of S character. That is 25% of S character is present in sp3. Whereas in sp2, it is 1 by 3. So when you say 1 by 3, it is 33% of S character and 67% of P character. SP, it is 50-50, 1 by 2. So it is 50% of S character, 50% of P character. Yes. So you should be knowing the percentage of S character, P character for sp3, sp2, sp hybridization. The complex ion CO stands for cobalt, NH3 6 times, hexaamino cobalt plus 3 is formed by sp3d2 hybridization. Hence, the ion should possess what geometry? So, this is based on VSEPR theory. So, according to VSEPR theory, a molecule with 6 bond pairs, here NH3, there are 6 molecules. So, it is a molecule with the 6 bond pairs and the hybridization is sp3d2. So the geometry of the molecule should be what? Octahedral. I'll just show you the geometry also for this. This ion is called complex ion. It is called complex ion. So geometry comes out something like this. CO. Here there are 4 NH3, 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 1 above and 1 below. So here NH3, NH3. Join all of them, you'll get the geometry. Yes. So this geometry is called what? It is called octahedral geometry. And here the hybridization is sp3d2. So there are 6 bond pairs. There are 6 bond pairs. Correct? So this is the geometry. So option octahedral geometry is the correct option. right? Next question, which of the following molecules does not have a linear arrangement of atoms? For linear arrangement of atoms, the hybridization should be what? Sp with a bond angle of 180 degrees. Where is it? It is CO2. Yes, observe. Do it. Sulfur, half. Valence electrons, 6 plus 2. It is 8. 8 by 2 is 4. So it is sp3. Correct? sp3. C2H2. Just now we have seen it is sp. Correct? And it is linear. BeH2. Beryllium, half. Valence electrons are 2 plus 2. 4. 4 by 2 is 2. So it is also sp. Correct? This is also sp. So where does not have linear arrangement, it is for H2S, because hybridization is sp3 and it is having angular shape. It is having angular shape. This is the shape for H2S. This is the shape for H2S. Yes? Okay. In which one of the following molecules the central atom can be said to adopt sp2 hybridization? Where we have sp2 hybridization? BeF2, same as BH2, it is sp. BF3, it is sp2. See, half. Boron is 3 plus 3. 6 by 2 is 3. So it is sp2. C2H2, just now we have seen sp. NH3 is sp3. So where sp2 hybridization is there? It is BF3 molecule. It is sp2 hybridization. Correct? Next question. Equilateral shape has. Equilateral shape. That is nothing but trigonal planar shape. So trigonal planar shape is for sp hybridization linear, sp2 is trigonal planar. Equilateral is nothing but trigonal planar shape. sp3 tetrahedral, sp3d trigonal pyramidal. Yes. Consider the following species: Cn plus, Cn minus, NO and Cn. Which of these will have highest bond order? See, we have seen for homonuclear, this is the question based on molecular orbital theory. So based on molecular orbital theory, if you want to write the molecular configuration of the molecule, so calculate total number of electrons. How many are there? Nitrogen, there are 7 electrons. Oxygen, there are 8. So total becomes 15. Write the configuration. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Since nitrogen and oxygen are there, sigma 2pz2 comes first. Then pi 2px2 equal to pi 2py2. Then comes what? Count the electrons. 2, 4, 6, 8, 10, 12, 14. I want 15. Next comes what? Pi star 2px equal to pi star 2py. And I need 2 more electrons. So 1 here, 1 here. Write the configuration like this. This is the first question. So I'm writing entirely. Calculate the bond order. What is bond order? Number of electrons in bonding minus number of electrons in anti-bonding divided by 2. So how many electrons in bonding? 2, 4, 6, 8, 10. 10 minus anti-bonding 2, 4 and here 2 electrons 6. 10 minus 6 by 2 is how much? 4 by 2. 4 by 2 is how much? Anti-bonding. Okay. 2, 4, 6, 8, 10, 12, 14, 15 electrons. I'm sorry. So here there is only 1 electron. So this becomes 10 minus 5 by 2. So 5 by 2 is how much? 2.5 for NO. Bond order is 2.5. Similarly, you have to calculate Cn minus. Cn minus. Carbon 6, nitrogen 7. So 6 plus 7 is 13. 13 minus means what? Plus 1, 14. Configuration sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then pi comes first because carbon and nitrogen. Pi 2px equal to pi 2py. 2 electrons. Then comes sigma 2pz2. Let us count. 14 should be there. 2, 4, 6, 8, 10, 12, 14. Okay. Bond order. Bonding electrons 2, 4, 6, 8, 10. minus anti-bonding 2 and 4. So 10 minus 4 by 2. How much? 6 by 2 is how much? 3. Third option, Cn. So how many electrons for Cn? It will be 13, correct? So 13 means this all remains the same. I'll write it since it is the first question on molecular orbital theory. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2 equal to pi 2py2, then sigma 2pz1, because here it is 14, here it is 13. So bond order 2, 4, 6, 8, 9. 9 minus 4 by 2. So 9 minus 4 is how much? It is 5 by 2 is 2.5. Then last one is what? Cn plus. Cn plus means what? Cn plus means 15 electrons. So configuration sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2 equal to pi 2py2. Cn plus means what? 12 electrons, correct? So Cn is this, Cn plus means 12 electrons. So this ends 2, 4, 6, 8, 10, 12, correct? So bond order 2, 4, 6, 8. 8 minus 4 by 2. 8 minus 4 is 4. 4 by 2 is 2. So here for NO bond order is 2.5. For Cn minus bond order is 3. For Cn bond order is 2.5. And for Cn plus bond order is 2. Question is, which one will have highest bond order? Where there is highest bond order, it is for Cn minus, because NO and Cn are having 2.5, whereas Cn plus is having 2, Cn minus is having 3 bond order. You are going to calculate it like this. So bond order is highest for, it is highest for what? It is highest for Cn minus. Cn minus. So you need not sit writing the diagram, molecular orbital diagram for all of them. Just write the electronic configurations. These are heteronuclear diatomic molecules. Yes, what examples we had seen were for homonuclear diatomic molecules, and these are heteronuclear diatomic molecules. So not to worry, you can add those electrons and write the configuration, filling up those electrons in the order of increasing energies of the molecular orbitals. Then you have to calculate bond order. Even we have questions based on magnetic properties, whether it is paramagnetic, diamagnetic. So we will solve more and more questions on molecular orbital theory also, so that we become perfect. When it is neutral molecule asked, what will be the molecular orbital electronic configuration? If it is ion, whether it is cation or anion, it differs. If it is a cation, it will have, you should remove the electrons. If it is anion, you should go on adding the electrons, and adding also follows all the three principles: Aufbau principle, Pauli's exclusion, and Hund's rule of maximum multiplicity. So with this, we'll stop the class here. In the next class, we'll take the next set of questions on molecular orbital theory and remaining part of the topic. Yes, please practice molecular orbital theory so that you'll understand the next questions very easily. For now, thank you.